Okay, so welcome back. This is part 4 in our series where we show you how to make a computer hardware monitor to monitor the sensors on your computer. In C# Visual Studio, we can monitor the sensors that provide information on, for example, CPU temperatures and fan speeds and voltages of the different components, the CPU, the motherboard, the RAM. And we showed you in previous videos how we can take advantage of a NuGet package from GitHub called Open Hardware Monitor that allows us to fairly easily access the data on our motherboard. And we showed how you can print it out and also how you can take some data and put it in a real-time scrolling chart so you can see over a period of 5, 10 minutes or 30 minutes, whatever, what's been happening to the temperatures of your CPU or whatever. So what we're going to do in this video is we're going to take a deeper look into what's actually going on and what is the actual hardware that's monitoring that on your motherboard and in your CPU. What's actually doing that, and how can we communicate with that hardware directly to get that data rather than having to go through a third-party library. So let's take a look at part of the application that we developed previously, C# Visual Studio. And here I've made a little modification where we're going to load the data, all of the data available from all the sensors on our computer, and then we're going to display it here, and then we can also save all that data to a CSV text file so we can look at it in more detail. So I'm going to press load sensor data. You can see it's loading. And after a bit, it's going to gather basically what seems like hundreds of bits of data for the computer. And you can see it's got a sensor with a name of a sensor and a value of the sensor at the time that it grabbed it. And again, we can do this in real time, but this is just one snapshot of the data. So what we want to do is we want to go back and see, well, what's actually the source of this data and how can we access it? So one thing I've done is I've added a save to CSV that takes all of this data, which each line of data, we've already shown how we can grab it. And what we're doing in this app is we're saving each line of data to a list of strings. And then I can hit save to CSV and it will give us a save file dialog where we can choose the path and save all of these lines into a CSV file. So I'll hit save to CSV, and I can just enter the name that I want it to go to, and the result will be this. And this is a nice way to have a file that you can basically scroll through and better understand what's going on with all this sensor data. So if we take a look at this, the first piece of hardware we're looking at is my motherboard. It's X370 Gaming Pro Carbon. So that is called hardware. And of course, that's what contains all of the components that we're monitoring. Now there's also in the next line, sub-hardware. And it's a Nuvoton NCT 6795D. And under the sub-hardware, there is a sensor with a name and a value for that sensor, which is a snapshot value grabbed when we ran this. So what is all this stuff? Well, the hardware obviously is the motherboard that contains the components and that interfaces with the external components like the storage and fans and so on. So if we search on this Nuvoton NCT 6795D, what we get is this. It is a Nuvoton LPCE SPI SIO, and that means it is what's called a super I/O. And this is a very, very complex chip that basically does a lot of the data acquisition, acquiring data from sensors on the motherboard. And you can see it's basically 520 pages in this manual for this Super I/O chip. So really, really very complicated stuff. And if you scroll through, you can start to see what's going on with this Super I/O. And if you scroll through this, you can see it has, for example, on one pin, input of temperature sensor 7, sensor 6, sensor 5, fan tachometer input 0 to 5 volts amplitude to all of these pins, fan speed control input. So you can see it does a lot of monitoring of a lot of things. It also has ATX power supply good signal. Power good, power supply on off output, so it can control the power supply. 3.3 standby power supply for digital circuits. And if you go down to the hardware monitor functions section, it kind of gives a general explanation of what hardware monitoring it can do. Smart fan control system, control fans, more fan control stuff, voltage, 14 voltage inputs, CPU V-core, VIN 0 to 9, 3 VCC. So you can imagine that if we can communicate with this, we can read different voltages on the motherboard, some more fan speed stuff, built-in case open and CPU socket occupied detection circuit. But you can see down the bottom it says provides I2C master-slave interface to read-write registers. So if you think about it, you can imagine if you want to, for example, read what the present voltages are on the motherboard, when the CPU V-core or whatever, you probably are going to be using I2C master-slave interface to read-write registers. So you can imagine a lot of the data we want to access is going to be held in some registers in this Super I/O, and we're going to use I2C to grab the sensor data and read it. So that's starting to give you an idea of what we're going to be dealing with, and you can imagine the other components on the motherboard, like the CPU and the memory and the storage, might have similar type of functionality. So let's take a look a little bit deeper into what this might include. So here we are back in Visual Studio with our GitHub repository, the entire contents of the Libre Hardware Monitor repository from GitHub. And you can see over here we've got the solution, Libre Hardware Monitor, and we've got the Libre Hardware Monitor lib. And that is the library that we referenced when making our blank project. We referenced that as a NuGet package. So what we're going to do is we're going to try to figure out in this hardware monitor library where it is interfacing with our Super I/O chip, and hopefully we can find a reference to that Nuvoton Super I/O and figure out, how does it know what registers, how does it communicate with the Super I/O and gather data, and then we can do the same thing for the other components. Now again, there's no documentation, so we're going to have to see if we can figure this out. We're in the Libre Hardware Monitor library. We're going to expand that, and you can see it's got hardware, battery, controller, CPU, GPU, memory, motherboard, network, PSU storage, and then a whole bunch of code below that. So since that Super I/O is on our motherboard, we can go down to motherboard and expand that, and you can see we've got a folder LPC, control, fan, identification, manufacturer, model, motherboard, motherboard group, Super I/O hardware. Aha! So we can click on that, and on the left here, hopefully we can find some reference to our Nuvoton Super I/O, and then at least get a feel for how this is laid out and how it's configuring the sensors on this and accessing them and what registers are being used and so on. So we can scroll down here. There's got a Super I/O hardware type. There's an interface hardware, create control sensors, blah, blah, blah. Get board specific configuration. Create temperature sensors, create voltage sensors. So we're starting to get an idea of how this might work. And if we go down here, you can see there are two methods that actually say Nuvoton. One is get Nuvoton configuration F, one is get Nuvoton configuration D. Now, after a bit of looking, I found out that the one that's more appropriate to us for some reason, I'm not sure why, is this D method. And it's got a switch case statement where you feed it the manufacturer, in our case MSI motherboard, and for the different cases, it's got ASRock, Asus, here's MSI, and for that model, which was an X370 Gaming Pro Carbon, we can go down and see if we can identify the specific Super I/O. In our case, it was an NCT 6795D. This one is for a 6797D, so maybe they've got ours, or maybe it just defaults. So we can scroll down, 6797D, 6795D. So here is our Nuvoton. It's a different model number of motherboard, but this shows a 6795D. And you can see what it's doing for that model. It's saying we're adding a bunch of voltage sensors, VCore, plus 5 volts, AVCC 3.3, and then it's adding some temperatures. So it's getting CPU temperature, auxiliary, motherboard, and it's got a bunch of fans, pump fan, CPU fan, system fan, and then some controls to control the pump, CPU, and system fan. So at this point, we have an idea that what it's doing is it is setting up these different sensors, and then at some point it's going to read those sensors, knowing where to look on the Super I/O and grab the data and bring it in. So now on the right here, if we scroll down a bit, we can see all of these presumably classes here: composite sensor, computer, firmware, hardware, interface, iComputer. And we can go down to a class called sensor. So you can probably assume that this is going to be generating sensor objects with these different properties, their voltage or temperature or fan or control. And maybe if we look at the sensors, we can have a good idea of how it actually reads the data from those sensors on this Super I/O. So I'm going to select sensor. And we've got a whole bunch of stuff here. We've got what hardware, what settings, track min max, list of sensor values. So maybe when it reads from the CPU, for example, or from the Super I/O, it gets a list of values into this list. Count. So as we saw before, we've got a float question mark. So maybe that is the actual red value, current value. So we can scroll down here. We've got sensor, and here is the constructor. You can see it's called a sensor class, and here is the constructor. So for each sensor, you can assume it's got a name, an index, sensor type, hardware, and so on. And we can scroll down here, and there's a whole bunch of stuff. But there is a method called get sensor value from settings. So you can assume that maybe this is where you've got the sensor set up and configured, and now you're going to read the value for each of the sensor based on what settings were input. So you're going to get a name and convert that to a string, settings get value, and then as long as this is not null or empty, there's a try catch here, and presumably this is where you're going to read the actual sensor value from, in our case, the Super I/O. Now, the problem is it's kind of complicated. We've got a memory stream, system I/O memory stream, and they're using, for some reason, they're using this gzip, which compresses the data, and then we're setting up this destination memory stream. We're using a binary reader called reader, and presumably that's down in here going to actually read the values. We're going to say there's a length of values to read. Presumably that's been calculated. While we still have more to read, we're going to do a reader.read single. So it's going to read a single value and append that to the values we read with the value and the time. And then it's going to decrement, and it's going to read the next one and read the next one as long as there's more to read. Now, unfortunately, getting into the details of this is a little bit more complicated. They're using this compression, and figuring out the memory stream, how that works, is another task. But we're starting to see how we can reverse engineer this, and we should probably see something very similar for the other sensors and the other hardware. Now, the problem is this really doesn't explain, unless you're really familiar with memory stream, what method it's using to actually read the data. So we'll have to look into that, but at least you're getting an idea of how this is working. So now what I'm going to do is I'm going to put a breakpoint in and run this. So in this get sensor values from settings, at this string S, I'm going to put a breakpoint here. And I'm also going to put a breakpoint down here when we do a reader.read single, which reads a 4-byte float, and presumably this is where we actually read a value. And I'm going to go through and see some of the results we're getting. So I run it, and the name we get is LPC/NCT6795D, which is the name of our Super IO/0/voltage/0/values. So it's giving us an identifier of the name of the value we're going to get. Go to the next breakpoint, and the value it reads is 1.224. And then we can look and see how this reader is reading a single float, where it's reading it from, and so on. So I think that's it for this one. If I get any interest or any views, I might do a follow-up video or two to dig into some of the details about how this actually reads the data from the hardware. I probably won't get any views, so I probably won't do it. That's about it for this one. If you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.